All right, so I am Alex Rickabaugh. As Naomi said, I work on the Angular team on mobile. Been on the team coming up on 2 years. I work with Jeff. And I'm here today to tell you how to rescue your mobile experience from flaky networks and slow devices. You may have heard Steven talking earlier in the keynote about how mobile devices are kind of underpowered. They run on batteries. And if we do bad things with their CPUs, then the users hate us and all these bad things happen. But I wanted to give you one more reason to care about this stuff. So I'm going to share some numbers from a study that Google's DoubleClick branch did. DoubleClick's one of our advertising groups. And they did a study looking at analytics data from the mobile web, thousands of sites, lots of data points, and they found some truly mind-blowing things. So yeah, one of the biggest takeaways that I had from this study is over half of mobile site visits are just abandoned. The users walk away if the pages take longer than 3 seconds. 3 seconds, 1, 2, 3, gone, right? And that doesn't mean that if you take 2.9 seconds, you're safe, they're going to stick around, right? So you can lose half your traffic just like that. Another thing that amazed me is just how bad we are as developers at getting this right. 3/4 of sites took longer than 10 seconds to load. The average was 19. That's crazy. Clearly, we can do a lot better. But how good is good enough? Like, what actually should we be aiming for? There's a lot of guidance out there, and some of it says, like, you should use this API and not this other API, or do things this way. It can be kind of confusing. So one of the better models that I found is the Rail performance model. This is something that Google Developer does, and it stands for Respond, Animate, Idle, and Load. And it's designed to be user-centric, so it's technology independent. It gives you a set of targets to aim for a user experience. Right? So we have to respond to all user events, that's input, scrolls, et cetera, within 100 milliseconds. We should be animating at 60 frames per second. We need to take advantage of idle time the user's not interacting with the application, in order to fetch more content that they might need later, stuff like that. We also need to load all of our major content. That includes the home screen in under 1 second, right? 1,000 milliseconds. That's a really aggressive target. It's very hard to hit. And I'm here to help you get there. So I like the sound of Rail so much, I decided to come up with my own acronym. This is Shell, Load, Boot, and Engage, or SLEBI. It doesn't quite roll off the tongue, and I'm still working on that. But these are 4 areas of performance that are critical to get right on the mobile device. So I'm going to go through each of them and talk about the architecture and best practices that you can use to get there. So the shell, the application shell. This is a concept that kind of confused me the first time I heard about it. But it's pretty simple. It refers to the state of a single-page application before the JavaScript executes. So here's what I mean. Right? When you go to a single-page application, the browser downloads index.html, and it starts to parse it. And while it's doing that, it's doing 2 things. It is looking for JavaScript and CSS and other external resources, and it's downloading them in the background. But it's also creating DOM nodes and starting to render the page. If you ever loaded a site over a slow connection, you've seen the page kind of like appear in increments right down the page, and that's what's happening. So there's a period of time when the index page is displayed, but the JavaScript has not downloaded and executed yet, and this is the application shell. We as developers tend to overlook this a lot. It's inconvenient to deal with, right? There's no JavaScript, there's no jQuery, we don't have our tools that we're used to, and it's only there for a couple of seconds. So we tend to ignore it, and that's why you get loading screens that look like this, right? It's just a message, or if we're lucky, an animated little spinner to kind of distract the user while we're loading some JavaScript and getting the real app up and running. And you know how to do this in Angular. It's pretty easy. You take the index.html page, you have the root component tags, and between those tags, you can put content that you want to show before the application boots. But there's so much more potential here, right? Many applications have a frame or some kind of static content shell in which they display dynamic content. Maybe it's a header or a side nav or something like that. And if you can get that on the screen as part of index.html, your application will feel a lot faster. So here's an example of one of these, right? We have a header, we have a loading bar. This application was a registration form, so we have a form. All of this is static. There's no JavaScript. I can't type in that input at the bottom and see the character counter increment. But if we can get this static picture on the screen right away, the application load will feel nearly instantaneous. So one way to do this is to just hand code it inside the root tag, right? Same as before. We have a style, we have our header, we have some forms and progress bar. And this will eventually get replaced once Angular actually loads. But this is really tedious, right? Who wants to maintain a static copy of their application alongside the Angular app? That's why we use Angular. We're not hand coding HTML anymore. So I recommend that you do this with Angular Universal. Universal is our tool for running Angular on the server, in addition to a few other places. And it's typically used for server-side rendering, rendering an Angular application as part of a web server's response to a request. But you can also use it at build time to generate a shell. And to do that, just like you write a module for bootstrapping your application in the browser, you write an ng module for bootstrapping with Universal. And you include the Universal module with some configuration. You can look at the Universal site for more details what goes there. But when you do this, you use a similar bootstrap process. You call platform universal dynamic, you serialize the module, and then you get some HTML out that you can use for your index page. Works really nice. So one of the things you might want to do while you're doing this is kind of take more control over which parts of your application are displayed during loading versus which parts are displayed at runtime. And you can use the app shell tools that we published with our mobile toolkit to do that. So you can install at angular/appshell and use the appshell module. At universal time, you'll want to use appshellmodule.prerender. And at runtime in the browser, use appshellmodule.runtime. And what that gives you is two directives, shell render and shell no render. And these work, they're opposites. One of them, shell render, will turn on content only in the application shell. And shell no render will turn on content only at runtime. So here we're using shell render to only show the loading indicator while the application is loading before Angular Bootstrap. We're also using shell no render to turn off this dynamic view, whatever that is, because we don't have any content to fill it during the application shell. So that's how to get much more of your application on screen faster, right? But now you're kind of racing to load JavaScript before the user starts to interact with that shell and realizes that it's not alive. So how do we optimize loading JavaScript into the browser? We're going to do this with two main strategies. The first is, as Mishko said this morning, we're simply going to transfer less code, right? Secondly, we're going to mimic a native application. When you install a native app from the App Store, it downloads its code and it saves it on your device. And then your application boots from that. It doesn't require a network connection. We're going to do the same thing with a service worker. So how do we transfer less code? Well, if you imagine this blue bar on the left here is your application, and on top we have the bit of Angular that you need to run it. The first thing we're going to do is split your application into an initial bundle which contains only the code needed to show the home screen, and everything else which we're going to lazily load in with the Angular router. Right? So this can make the part of your application that you need to transfer much smaller. Then we're going to use the Angular ahead of time compiler. And you saw this morning how that transforms templates into factories, but it also means that you don't have to transfer the parts of Angular that deal with compilation. So now this amount of Angular that you have to transfer gets a lot smaller. And the last step is one of the most exciting things to me, and that's tree shaking. Tree shaking is something which was not really possible in JavaScript before, but with ES6 modules is becoming kind of a feasible thing to do. Previously, if you're using jQuery or something like that, you have to pay the cost to ship all the bytes of jQuery down to the client, even if you're using one or two functions out of it. And now, with tools like Rollup and Webpack 2, we can actually eliminate code that you don't need from your bundles. So you probably know that Angular Forms has both template and model-driven or reactive forms. If your app is only using template-driven forms, you're only installing Forms module, tree shaking can come along and actually remove the reactive bits from Angular Forms when it compiles it for your bundle. So Angular gets smaller because you don't use parts of it. That gets really powerful. So now let's talk about service workers. We all know how the web works without a service worker, right? The browser encounters a script tag, it goes to the server, downloads the script, and this tends to happen every time the user goes back to your application. With the service worker, though, we can actually install that script on the device, save it in local storage. So the next time they come to the page, the service worker loads the content locally, and you don't incur a network round trip. It gets a lot faster. So how do we do this? There's a few different ways. You could write your own service worker, You could go find one of many kind of pre-published implementations. Ours is one of them. We have a service worker with the mobile toolkit. It's designed to integrate into Angular. You can install it with npm at angular/service worker. You install it, you copy the script from the bundles directory into your deployment directory, and now you have a service worker. All you have to do is install it in your HTML. But then you need to configure it, right? The worker needs to know what resources, what URLs to go and fetch and install. So the next time your application loads, it has all of the resources it needs right there on the device. So to do that, you're going to write a manifest. And this is going to be a recurring theme for the rest of this talk. So in the manifest, you include the URLs that you want to load and hashes for the content. And you need those hashes so the worker knows when things change. It knows when to go and update your application. And this gets really tedious to maintain by hand, so don't do that. We have a Webpack plugin. So if you're using Webpack to do your bundling, just install their plugin at the end of your Webpack configuration, and it'll generate the manifest for you. It'll calculate the hashes and do everything correctly so your application will update without any problems. So now you've optimized the initial load, right? Your application is just about ready to start up. Now Angular needs to bootstrap and take over. And that's where ahead-of-time compilation really shines. As you saw this morning in Lucidchart, right? In JIT mode, the first thing Angular does when it boots up is compile all of your components, all of your directives, all of your pipes, generates code for them, and it takes a while. In AOT mode, that's already been done for you. That's moved to a build step. So when you call Bootstrap module factory, Angular just starts creating stuff on the page. Nothing slows it down. It gets really fast. For a large application, that can mean several seconds of compilation down to milliseconds. But once Bootstrap happens, a lot of applications still need to go and get data. And the key here is to be smart about how you do that. You only want to fetch the stuff that you need to show right away. Everything else should be done while your application is idle, like Rails says. Also, if you can ship the initial data in index.html, if your server can generate that page and include a blob of JSON that later gets read out, that speeds things up considerably because you're not waiting for the JavaScript to download and execute before you even begin making API requests, right? And you should also cache data. Never underestimate the effectiveness of good caching. We'll talk more about how Service Worker will let you do that soon. And the last thing I want to talk about is initial state. I see applications get this all wrong all the time, right? The developer is working on their workstation. They have a fast internet connection, and so it looks fine on their device. But on a mobile phone, when an API call happens, it can be a second or more before data comes back from the server, right? You have the latency of the mobile network and the server together. And quite often, the user's left hanging when this happens. There's parts of the UI that are on screen but not filled in. You don't show a loading indicator for certain things, so pay attention to that intermediate state again. Just like with the application shell, you need to make sure the app looks good even while it's loading. So I wanted to talk about this upcoming feature in Service Worker. This isn't released yet, but it should be in the next couple weeks. This is dynamic content caching. So whereas before we're using the Service Worker to install a predefined set of content on the device for later loading, with dynamic caching, you can give it a set of URL patterns to match on the fly. And it will cache requests to those URLs with a variety of strategies. And you can even say for a particular URL, if a mutate request happens, go and invalidate some other part of the cache. So this works really well for caching RESTful APIs. So the last area where you can improve the user experience is in engagement, turning users into repeat users. And we're going to borrow two capabilities traditionally associated with native applications to do this. The first is installing to home screen, getting a launcher icon on the user's desktop. The second is push notifications, delivering content and updates asynchronously. Install to home screen is actually really easy. We just need another manifest. There's a lot of these running around. So this manifest declares the name of the application, the startup URL, and some information about how you want it to be displayed. Do you want it to start up in a browser, or do you want it to mimic the look and feel of a native application? And once it's installed, the icon looks like just any other application on the phone. You can't even tell it's a mobile app. It's kind of awesome, actually. So install to home screen is simple. Push notifications are not. This is a complex machine, and I'm going to walk you through it. So when you send a push notification, what you're trying to do is from your back end, communicate some message to the user. So you do that using a push service. The back end makes a call to the push service, delivers the message and some credentials associated with the user. And the push service is responsible for contacting the service worker running in the browser and delivering the message. And the service worker will show a notification. On a desktop, it looks like a pop-up like this. On a mobile device, it'll show up in the mobile device's notification tray. It's really well integrated into the mobile experience. So the Angular service worker supports push notifications out of the box. You can do it with more manifest configuration. So the first thing you do is in the service worker manifest, turn on push notifications by saying show notifications true. Then you have to go through a sign-up process on Google Cloud projects to create a cloud project and configure it with cloud messaging. And there's all kinds of guides on this. I'm not going to walk you through the details. But eventually, you'll get this thing called a Google Cloud Messaging Sender ID. And that's what you stick in the web app manifest. That's the manifest that we used for install to home screen. So once you've done that kind of boilerplate setup, now you need in your application to actually turn on push notifications, to register to receive them. And you can do this with the service worker module from our Angular service worker package. So you install that module, and it lets you inject this API called ng service worker. It's an API that you can use to communicate with the Angular worker. One of the things it can do is register for push notifications. So you call ng service workers register for push, and you subscribe to it, and you get this thing called an endpoint. And it's a big JSON object with some keys in there and the URL and some other things. The details aren't really important, but that's the object that you send to the server. And that's what the server needs to know how to contact this client in the future, even when your application is not running. So on the server, once you have this endpoint, you can send one of these things. You have to either implement the spec yourself or use one of the convenient packages on NPM, like Web Push, to do it for you. So you take Web Push, you configure it with your cloud messaging credentials, and then you want to send just one of those pop-up notifications. So you send it a JSON payload. And in this payload, you have a notification object. And the notification object configures how the notification will look. This is the Angular service worker making it easy for you to just configure the UI you want to show from the server. So you send the title, the body, an icon, maybe some details of what actions the user can take. And then the Angular service worker will just show that as a pop-up for you. That's nice, but if you want to send some extra info that's not part of the UI, you can definitely do that. From ng service worker, you can access this push observable, and this push observable gives you the entire payload. So if your application happens to be running while you get a push notification, you can access any extra data that you want to send down, and maybe update or refresh your UI or do something special there. So that's all I have for you today. In the near future, we're going to be working on some better documentation and guidance, particularly around Webpack on our mobile site, mobile.angular.io. We'll be working on bringing mobile support back to the CLI. We had it while the CLI was in alpha. It was kind of broken with Webpack, but we'll be bringing that back. We'll be working on integrating App Shell and Universal into other build systems. So things beside Webpack, if you're using a roll-up-based build or something like that. We'll be adding more integration in between Angular and the service worker, particularly around things like the routing configuration, being able to have the service worker understand your routes and deal with them automatically, and lazy loading bundles, some more intelligent logic on when they're downloaded, how to cache them, how to update them, and also tweet out my slides. So if you follow me on Twitter, you can look at the code examples there. So that's all I have. Thank you very much.